Hello everyone, my name is Hemu and today I'm going to discuss Palo Alto Firewall Demo. So before starting the demo session, let me just tell you about ourselves and how we are planning this particular training. So we will go through with all these details. So guys, this particular training or this particular batch, we are just covering two technologies. So first we will start with Palo Alto Firewall, and once Palo Alto Firewall complete, we will start this F5 LTM. And in most of the time we are having this particular combo batch, Palo Alto plus F5 LTM, because these are the two technology which have a huge demand in the market. Okay, and in most of the interview you will see they are asking questions on Palo Alto, they are asking questions on on F5 LTM, right? And this particular training I'm starting from 3rd August, and the timing of this training is 9 a.m. to 12 p.m. IST, and fees for this particular training is 12,000. And guys, these are the contact numbers. If you are interested, you can basically contact us on this number owned by me. So if you have any type of technical things or you want have any type of enrollment, you can contact me on this number. The second number belongs to Bidit sir, so you can also reach out to him. And third number belongs to Charu ma'am, so you can also reach out to him in case of any issues. Okay. Now, and guys, if somebody only want to enroll for Palo Alto, they can able to do that. And the fees for single Palo Alto firewall is 7,000, and there is no EMI type of options. Okay, and you can also further discuss if you have any type of query regarding fee and all on these particular numbers. Okay, so this is the details about the batch. Now, to complete the Palo Alto firewall, I need around 8 beacons. So there are total of 16 classes, and if needed, I can also increase one or two classes if required. Okay, there is no any hard and fast type of rule. I have to complete on 8 weekends. If I need extra time, I give that time. That's not a problem. Okay, and for FILTM, we generally used to have this training between 6 to 7 weekends. So there are total of 12 to 13 classes. First, we will start with Palo Alto, then we will go for F5 LTM. Now, guys, this is our website, Sianets.com. So you can get our details into that particular website. We do have a video portal. So this is the URL of our video portal, vncph.courses.store. And in this particular URL, you will get all the course offered by us. All the courses are available here. So if somebody just interested for the courses like the video based trainings, you can purchase these courses from here. Okay. We do have this particular portal as well. So like these both are the same portal only, just we have a two URLs, right? So this is a video portal, and guys, for each and every session will be recorded, and you will get the access of these recording through this particular portal with the lifetime access. Okay, so you will have a lifetime access of this particular trainings through our portals. We have a two YouTube channels. So this particular YouTube channel belongs to me, and in this particular YouTube channel, you will get lots of videos on Palo Alto Firewall, on Panorama, on Palo Alto troubleshooting, on AWS, right? Checkpoint, SQASA. So you will have a hell lot of videos here in this particular YouTube channel. So you can basically, if you will type hemu sir, you will basically get this particular channel details. Or if you will type Sianets, you will get our details. Okay. We have another channel. The channel name is Skill Inspirational Academy. And in this particular channel, you will get so many videos on the Wireshark. You will get lots of videos on F5 LTM, GTM, ASM, Python for network at automation, Fortinet firewall, checkpoint firewall, right? So you can basically also check out these particular channels, how we used to give the trainings and all, right? If you will go into this playlist section, you will get lots of videos here, right? These are the playlists I'm having here. Okay. So this is our details. Now, guys, let me just tell you what are the things you will get in this particular training, or what are the things we will be covering, right? So, sorry, I forget to edit this slide. Okay. So, this particular Palo Alto training is around 48 hours of training. You will get the lifetime interview support. Means if you have an interview, you can reach out to us around 3-4 days before, and we can take a mock interview. We will help. We will share a couple of interview questions and all, right? And we will check you are well prepared for that particular interview or not. You will get the documents. So we will share couple of official Palo Alto documents, and you will also get couple of documents which is created by myself. You will get the record access of all the recordings with lifetime access through a video portal. We will help you building the lab in your laptop, so where you can able to perform all the practicals. So let's suppose your laptop is not having good sufficient CPU, sufficient RAM, sufficient hard disk. In that case, we can help you building the lab over the Google Cloud, because if you build the lab on Google Cloud platform GCP, you will get a free lab for 90 days. Because when you register for Google, they will give you around 24,000 INR as a free credit. So we used to rent out a server of 32 GB, and we will build the entire lab into this particular server. Okay, so we have both options here. But I'll recommend, if you have a laptop with 8 GB RAM, you can just upgrade until 16 GB, and you can basically build your lab in your local laptop. Because if you have a lab in your local system, you can able to practice anytime. Okay. It's a weekends classes, guys. So your classes will happen Saturday and Sunday. During the classes, you can also discuss any type of issues if you are facing in your production environment. You can basically discuss the lab related issues during this particular time. And guys, generally we are available between 7 p.m. to 8 p.m. Monday to Friday. So also during that particular time, you can call us, you can WhatsApp us. We are available and we will help you with that. You will get the mock interview support as well with each and every students who will enroll for this particular training. Okay, so these are the things which we are going to cover now. Let me go through with the Palo Alto Firewall course content. What are the things we are going to cover in this particular training? Okay, so in the course content, I generally start your class, which is what is firewall. This is my first topic. Okay, and because generally I used to start these classes from very basics, because I have seen in my classes people are from the routing switching background or from some other backgrounds, right? Maybe they don't have a knowledge of security, right? So I will discuss like with the what is firewall, right? Then we will discuss next generation firewall versus legacy firewalls. What are the main difference between them, right? I will discuss SP3 architecture, which I will also cover today. And I will also discuss the stateful inspection, because when this stateful inspection technology is discovered by the industries, that the behavior of the inspection behavior of the firewalls is completely changed, right? So we'll discuss that particular strategy as well, right? Then I will discuss the platform and architecture. In platform, we will discuss like what type of offering or what type of hardware offering or the VM series devices offered by the Palo Alto firewall, right? What do you mean by the 200 series firewalls? Then they have a 400 series firewalls, right? Then they have a 800 series. Now they have recently launched 1400 series, right? Previously they will be having 2000 series, but it is there right now, it is not available because it is end of life, end of sale, right? Then they have a 3000 series. This is also end of life, end of sale. Then they have a 3200 series. Recently they have launched 3400 series, right? Then we have a 5000 series boxes, 5200 series boxes, 5400 series boxes, 7000 series boxes, right? So we will discuss all these hardware platforms. I will discuss the virtual platform as well. What do you mean by the VM50 firewall? Then we have a VM100, we have a VM300, then we have a VM700, and we do have a VM specific on the basis of CPU and memory for your cloud related environment, like in AWS environment or GCP environment, right? So I will discuss all these platform offerings. I will discuss the architecture. What is the internal architecture of these firewalls, right? What is the SP3 architecture? Because in every interview of Palo Alto Firewall, you will see they will ask the question, what is SP3 architecture? Or can you explain the single pass software and parallel processing architecture? Or what is the architecture of Palo Alto 5? And today also I will discuss the same topic. So this is the very hot interview questions in your Palo Alto domain. Okay. Once this particular thing, this single pass architecture will complete, after that I'll just move towards the flow logic or life of a packet inside the PAN OS. Means whenever any packet received by the Palo Alto firewall or the Palo Alto operating system, which is PAN OS, how this particular packet is handled by this particular Palo Alto firewall, right? So I will discuss the entire flow logic. What is ingress stage, right? What is ingress stage, what is flow lookup, right? Then what is session setup state or silo path, what is layer 2 to layer 4 processing or the first path, what is app id, what is content id, what is the forwarding stage, right? All these particular stages we will discuss in detail. Okay, then we will discuss the initial configuration, initial access to the system, right? Let's suppose you want to access this particular firewall initially, right? How you can basically access this firewall initially, like how you can do the management interface configuration, how you can take the console access, right? And how you can basically take the SSH access, how you can enable the ping on the interface, how you can limit the management access, right? All these things I will discuss in the initial configuration, right? What are the ways we are having to access this particular firewall, right? Then we will discuss configuration management. We will discuss license and software updates, right? What type of license offered by the Palo Alto firewall? What are the software updates, or how we can basically do the software updates on the Palo Alto firewall, right? So all these things I'm going to discuss. Once this part will complete, I'll move towards the account administration. How we can basically create an account for L1 engineers, for L2 engineers, for L3 engineers, how we can basically restrict the access of your devices, right? So we will discuss this account administration. How we can do the integration of this Palo Alto firewall with the Radius and with the LDAP server or with your Active Directory AD server, right? Because in every organization they used to have their user database into Active Directory, right? So we will discuss how we can integrate them and how we can basically use these particular external servers where we have our user database for the authentication purpose or for the login purpose on the Palo Alto firewall. Then how we can basically create a different admin roles. Okay. Once this part will complete, I'll move towards the interface configuration. How we can create a security zones. What is layer 2 deployment in Palo Alto firewall? What is layer 3 deployment? What is virtual wire deployment? What is step mode deployment, right? This vWire deployment and layer 3 deployment you will see in most of the time. So guys, in most of the classes, around 95% practicals I'm going to do with layer 3 deployment. With regards to this virtual wire deployment, what I'm going to discuss, I will basically have a one dedicated session where I will discuss how you can configure HA between in your virtual wire environment, right? And how you can do the deployment, how you can do the traffic forwarding. I will discuss what is step mode deployment. So all these particular deployment we are discussing with regard with practicals. Then we have a sub interfaces, right? Where we will discuss concept of sub interfaces, how we can create the sub interfaces. We will discuss DSCP, how we can make Palo Alto Firewall as a DSCP server, as a DSCP client, or as a DSCP relay agent. Then we will discuss virtual routers. Let's suppose you want to configure the routing in your Palo Alto Firewall. Then you have to basically create the virtual routers. And on these virtual routers, you have to basically do your routing. You can configure static routes, your dynamic routing protocols, right? Let's suppose you have a multiple virtual router, like we have a VR1, then we have a VR2 and VR3, right? How we can enable the routing between these three different VRs, right? And I will also go through with the use cases. What is the main use case of this multi VR setup? Once this particular part will complete, there is a one more thing I wanted to cover here. So after this, like your multi VR setup, here I will also cover your policy based forwarding, PVF. I will cover your path monitoring, policy-based forwarding, your path monitoring, and your equal cost multipathing ACMP. These topics also covered during this particular time only. Okay. And for this particular things, I am going to use this particular lab. In this lab, you can see I have a Palo Alto firewall, then I have a outside zone, I have a inside zone, I have a DMZ zone, and I have a guest zone, right? And this particular topology I will use for doing your static route configuration, your path monitoring, your policy-based forwarding, your ECMP, and your dual ISP setup. We have a Airtel ISP and we have a Tata ISP. How we can do the configuration, everything we will do in this particular lab. Okay. After that, we will discuss security policy and net policies, right? In security policy and net policy, I'm going to cover how we can basically create a security rules, how we can do the security policies administration, right? How we can create the static net, dynamic net, your destination net, your U-turn net, how we can create all of them. Because the security policy and net rule, these are the core functionality of any firewalls. Okay, so we'll discuss security policy configuration, policy administration. In net, we will cover source net, destination net, right? U-turn net, D. So all these particular net I am covering here. And guys, for these two topics, I used to take around 6 hours. So there are dedicated 2 classes for these security policies and net rules. Okay. Here I will discuss what is the intrazone default rule, interzone default rule, right? So all these things I'm going to cover. Once this part will complete, I'll move towards the application identification or app ID. So app ID is a core feature of your Palo Alto firewall. So we'll discuss app ID overview, application groups and filters, how we can create a group, how we can create application groups, like how we can groups multiple application into a single group, right? How we can create a filters on the basis of technology, on the basis of application category, on the basis of risk factors, right? And how we can utilize them in our security policies. In your app ID, I will also go through with that how Palo Alto firewall is going to do app identification for TCP based packets, for UDP based packets, right? And what are the app ID component? What are the component available in your app ID to perform this app identification, right? What is app ID signatures? What is heuristics checks, right? What is app override policies, right? So everything I'm going to cover in your app ID. Then your content ID. Content ID is the main feature of your Palo Alto firewall, where we will discuss antivirus protection, anti-spyware protection, vulnerability protection, right? How we can basically protect our environment from the virus, how we can enable this antivirus protection in a Palo Alto firewall, how we can protect our environment from spywares, how we can protect our environment from vulnerabilities, right? So all these things I'm going to cover. Then we will discuss URL filtering, right? How we can do the URL filtering in your Palo Alto firewall. External dynamic list, file blocking, wildfire, right? All these particular features I'm going to cover here. For URL filtering, we have a dedicated 3 hours of session where we will cover how we can basically use the custom URL categories, how we can use the predefined URL categories, what are the different actions we are having with regards to your URL filtering, right? So everything I'm going to cover here. We will discuss the file blocking, how we can restrict the file upload downloads in our environment. Then we will discuss the wildfire, right? How we can protect our environment from the unknown malwares or the unknown malicious domains, right? Using the wildfire feature, because wildfire is a some type of sandboxing feature. Then we will discuss zone protection and DOS protection. See, your app ID and your content ID, these are the layer 7 features, right? So if somebody is basically sending any type of malicious payload at layer 7, we can protect with the help of content identification. But how, let's suppose somebody is trying to launch an attack using layer 3 and layer 4 information. Like somebody has sent the SYN flood attack or UDP flood attack or the ICM flood attack, right? Or let's suppose somebody has modified some of the headers, right, at layer 4 or at layer 3, and they are sending these type of malicious these type of packets. How we can protect? Let's say somebody is doing IP spoofing attack, right? How we can protect from these type of attacks? So for that we have a zone protection and DOS protection features. So we will be having a dedicated lectures on zone protection and DOS protection. We are going to do all these particular labs practically, and I will use my Kali Linux machine for launching all such type of attacks. Okay. So in Kali Linux, we have a multiple frameworks. We will use these frameworks to launch such type of attacks. Then we will discuss decryption. Decryption is a most important feature. Guys, tell me one thing. Let's suppose you are making a connection with one of the HTTPS website. What happens? Let's say this particular PC is trying to connect with one of the server. That server is hosting their service on TCP 443. So when he will basically connect with this server, they will make a SSL connection, right? Now through inside this connection, whatever information they will exchange. It is encrypted by a TLS, right? Transport layer security. And let's say we have a firewall here. Is firewall able to see this encrypted information? No, he is not able to do that, right? And we are not sure what type of communication is happening between this server and this particular client. Maybe they are exchanging some type of malicious content, right? So to allow the firewall to read your layers of information or to read your encrypted information, which is encrypted by the TLS, what we have to go with the decryption. So in decryption, I will discuss your SSL handshake, right? Then I will discuss how you can configure the inbound SSL decryption, outbound SSL decryption, right? How you can do the certificate management. Means I will discuss what is root CA, what is intermediate CA, then what is the end user certificate, right? All these things I'm going to cover here. Okay. So SSL handshake, your outbound SSL decryption, then your inbound SSL decryption, and I will also discuss SSH decryption, because nowadays people are making SSH tunnels and they can basically send any type of content through these particular SSH tunnel. So how we can secure the traffic through this particular tunnel, right? So for that we have to configure the SSH proxy in your firewall. So we will do this particular practical. Let's suppose I will host one of the SSH service on outside, and we will see through this SSH tunnel I can send any type of traffic. Then I will enable this proxy in your firewall, and we will see now firewall is restricting the SSH tunnel related traffic. And after that I will discuss the user ID, user identification. Then we will discuss the AD integration, Active Directory integration. Then we will discuss user to IP mapping, how we can create a user to IP mapping. Because in the environment, guys, what used to happen? All the PCs, they used to get the IP address by a DHCP server, right? If you are getting the IP from DHCP, then how you can basically put the restrictions on the basis of IP address, right? So what we can able to do, let's suppose we have a certain servers and we want to check if somebody is accessing these servers, what we want to see the username of that particular user. For that, we have to go with the user ID configuration in our environment. So where we will see how we can achieve this user to IP mapping, what is the PAN OS in built-in user ID agent, or what is the external PAN OS user ID agent, right? We will install these agents and we will see how we can achieve this task. We will see the group mapping as well. And after that, we will discuss the captive portal as well, how we can use the captive portal. Okay, so all these particular practicals I'm going to discuss in your user ID class. Once this particular class will complete, then I will discuss your IPsec site-to-site VPN, where we'll discuss phase 1 and phase 2 exchange process, like what is the main mode, what is aggressive mode, what is quick mode, right? Like we will discuss what is DH exchange, all the everything we are going to discuss in detail. Even though on these particular topics in VPNs, you will found lots of videos on my YouTube channel. So you can maybe check it out there. I have explained so many things there with regards to IPsec. Then IPsec tunnels, right? And I have mentioned around 13 use cases of your IPsec VPN. And I will try to cover in your live sessions, I will cover 3 to 4 use cases. And for the remaining use cases, I will give you the recorded session because I have created created the recordings for all the use cases. So I will share the recordings for couple of them, and couple of them I will try to cover in your class. Okay. Then we will discuss global protect. So we will discuss global protect. We will discuss the global protect connection flow, global protect connection method, what is the user logon on demand, then pre-logon on demand, pre-logon, then user logon, right? All these methods. And you know, this connection flow is most important, guys. If you are doing any type of troubleshooting, you have to know this particular connection flow properly. Okay. So we will discuss all these things in your global protect. So I think global protect is I needed around 2 classes to complete your global protect, all the methods and everything. And after that, guys, we will discuss your high availability, where we will discuss active passive high availability, configuration of active passive HA, active active high availability, configuration of active active HA, then floating IP HA lab, rpload share HA lab, mixed mode HA lab. All these particular things I am going to cover. And after that, guys, I will take couple of troubleshooting webinars as well. And I will allow you guys on these webinars. We will discuss what is packet filter, what is packet captures, and what is flow basic, all these troubleshooting utilities. Okay. So this is the course content, guys, of your Palo Alto Firewall, which I'm going to cover. Now, before going into today's topic, guys, let me show you what are the lab topologies I'm going to use. And guys, these labs I will share. So, you know, for static routes, for path monitoring, PVA, PCMP, I will use this particular lab topology. For not this one, for IPsec VPN, I'm going to use this particular lab topologies, right? Where I have a firewall 1, firewall 2, firewall 3, and ASA firewall. And this entire topology we will use for VPN related practicals. For layer 2 deployment, this is the lab topologies I'm going to use, and I will share all these lab topologies, guys, with you. Okay, so you don't need to create them. Then this lab topology I will use for your high availability practicals, for your HA practicals, active passive and active active both. Then I do have a lab for RIP OSPF, right? So I will also share you these topology. Like if you want to test your OSPF stuff, you can use this particular lab topology and you can do it. And I will give you the recorded session of this particular lab. Okay. Now I do have this lab topology I will use to explain the vWire concept, virtual wire concept. And I'm also working on one more lab topology. It is yet to complete. This is a master topology, right? So maybe by between your sessions, I will cover that topology as well. So maybe I will also give you that one. So here you can able to do all the practicals just in single topology. Not this one, Palo Alto. And I do have one more. And you know, guys, this is a lab set like topology. So around your like practicals with regards to your app ID, your URL filtering, right? We will going to use this particular lab topology for that. Okay, so these are the labs which I'm going to use. And you know, I have a basically lab setup on my VMware, but it is exactly like that only. So you can prefer EVNG doing the all labs because it is that like that only. But I used to do everything on my this particular VMware where I have these are the vulnerable machines, right, which I can utilize for launching any type of attack, right? Then I have couple of test PCs, right? Then I have a panorama, I have a two firewalls, I have a these servers, right? So I have a everything. I do have a Palo Alto migration tool as well, right? So this is the entire setup, and I'll explain you how you can build that type of setup. That's not a problem. Okay. Now let me just explain you today's topic, which is SP3 architecture. So you know SP3 stand for, so it's a SP3 is a combination of two things: single pass software plus parallel processing hardware. So SP3 is a combination of the single pass software and parallel processing hardware. So first I will try to explain what is parallel processing hardware, or what is parallel processing hardware architecture of your Palo Alto firewall. And once this part will complete, you will easily understood this SP3 or this single pass software. Okay. Okay. So you know, in this particular diagram, you know, first I wanted to tell you, in your Palo Alto firewall, we have a two things. In your Palo Alto firewall, we have a management plane and we have a data plane. Okay, this management plane is responsible for doing the management related activities like your configuration management, your reporting, your logging, right? This is the actual job of your management plane. Plus, in your generally your Palo Alto Firewall operating system, this PAN-OS, this operating system is based on Linux kernel. And guys, if somebody has worked with the Linux environment, in Linux we have a processes, right? Or we have a daemons. Okay, so you know, in management plane, most of the daemons of your Palo Alto firewall is a part of management plane. Then we have a data plane. Okay, in your Palo Alto firewall data plane, what they have done, this data plane is responsible for users traffic. So whatever traffic is initiated by a users, that particular traffic is processed by the data plane in your Palo Alto firewall. Okay, so now you can see here in this particular diagram, we have a control plane, which is known as management plane, and we have a data plane, right? And this particular management plane, as I have mentioned, it has their dedicated responsibilities, and data plane has their dedicated responsibilities. And guys, you know, this management plane has a dedicated RAM, dedicated CPU, and dedicated SSD. And your data plane is also having dedicated resources: RAM, CPU, and SSD. They have a dedicated resources. Okay, so means there is no resource level dependency on each other. Now in your Palo Alto Fire, this data plane is further divided into three another planes: networking, security, and content. Now why they have divided this particular data into three another component? You know, these three components are the dedicated hardware chip, or I can say ASIC. These are the dedicated hardware component, I can say. And the responsibility of networking chip to process the traffic on the basis of layer 2 to layer 4 information. But you know, this network processor is also act as a offloader, session offloader, and I will tell you what is this session offloader. This security processor is the is a main processor, and this particular processor also known as DPCPU. Then we have content engine. This content engine is also known as a signature match processor. And the task with regards to layer 7, like your app ID and your content ID, done by this particular signature match processor. Because in your Palo Alto firewall, this data plane, it has a dedicated hardware component for doing the dedicated jobs. And these processor is not having any type of resource level dependencies. Means that suppose if network processor is overutilized, then security processor will not impact. Security processor will do his jobs. So that type of architecture they are having at the hardware level, means they have a function specific parallel processing hardware engines. These are the dedicated hardware engines. We have a separate data plane and control planes. Means if you are sending some type of traffic for management related stuff, then your management plane is responsible for handling this traffic. Data plane has nothing to do with that. If some data plane traffic is coming, then data plane is responsible for handling this traffic. Your management plane is nothing to do that. Let's suppose somebody launched the DDoS attack in your data plane. If somebody launched the DOS attack in your data plane, your management plane is safe. You can log in into your management plane and you can make the necessary changes in your firewall, because configuration management, we have to do it from here. Okay. And let's suppose somebody has launched any type of DOS attack in your management plane, then your data plane is safe, means your user traffic will not impact. So that is the parallel processing hardware. Okay. Let me just go down here. Now, by looking into this diagram, you will get the pictures properly. So, you know, as I have mentioned, we have a management plane, MP, and we have a data plane, which is DP. Now, you know, this management plane is responsible for your configuration management, your logging, and your reporting. Plus, we have a lots of management related daemons. Lots of daemons. Let's take an example. Let's suppose for IPsec. For IPsec VPN in your Palo Alto firewall, the very first daemon is which is IKE Manager. The second daemon is CryptoD. Then third daemon is IKE Manager, CryptoD, KeyMGR, and fourth daemon is your tunnel D. Now you know, out of these four daemons, your IKMGR, your CryptoD, and your key manager, they are running in your management plane. Your tunnel D is a daemon who used to runs in data plane. So we will discuss all these things in your IPsec class. Okay, but here I am just giving you the overview. Okay, now. So your management plane has a dedicated CPU, dedicated RAM, dedicated SSD. It has a dedicated management plane, dedicated console port, and it is also having dedicated HA1 interface. And your management plane is responsible for the configuration management, logging, reporting, function as a separate processor, RAM, and hard drive. Okay. Then we have a data plane. Now, you know, in this data plane, we have a network processor. Network processor is responsible for the flow control, MAC lookup, route lookup, QoS, and net. Means, as I have mentioned, it can able to do the layer 2 task to layer 4 task. Means it can able to process the packet on the basis of layer 2 to layer 4 packets. It can able to do that. Then we have a security processor. Security processor is responsible for your user ID, your SSL related tasks, generally, in your Palo Alto firewall, we have a dedicated SSL engine. Okay, and this dedicated SSL engine is responsible for doing this decompression, SSL and IPsec related task. Okay, then we have a signature match processor. This signature match processor is totally responsible for app ID and content ID. Now you may ask why they have mentioned this app ID here. They have mentioned this app ID here because this particular engine will do the app identification. It will tell you this traffic belongs to Facebook. Now the final security policy enforcement done by the security processor. Okay. So guys, if you have noticed here, we have a parallel type of architecture, right? We have your data plane is further divided into 3 other planes, and these particular planes is doing their responsibilities dedicatedly, right? That is known as parallel processing architecture of your Palo Alto firewall. I hope you got the point here with regards to this parallel processing architecture. Now let me just show you one more diagram so it will clear the things. So if you will see this particular diagram, because in your live sessions I will basically explain this diagram in detail, but here I'm just giving you the overview. So this particular diagram is known as a block diagram of your Palo Alto firewall. This is a block diagram, means how Palo Alto firewall going to do the packet processing. So it will have these type of component. So first we have a interface card where we have your interfaces like copper interfaces and the fiber interfaces. All your copper interfaces will have a connectivity with the Marvel chip. All your fiber interfaces, they have a connectivity with the Petra chip, or SFP plus ports have a connect with the Petra chip. Then this particular Marvel or Petra chip, they have a connectivity with the Liger engine or Tiger engine. This is known as your network processor. And this network processor is a session offloader. Guys, this processor is not available into all the hardware models. I am taking an example of very high-end model like 3200 series box, 3400 series box, or 5000 series box, or 5200 or 5400 box. Okay. Then we have a Octeon chip, which is known as data plane CPU. And this is known as security processor. Then we have a Jaguar chip, which is responsible for doing the signature match processor. This is also a FPGA. And this particular processor is responsible for app ID and content ID. These tasks done by this Jaguar chip. This Jaguar chip is also known as pattern match processor or signature match processor. Okay. And guys, let me just show you one more diagram. If you will see this particular diagram, this is the packet flow diagram of Palo Alto firewall. So I'm just going very in a very high level here. So when packet received by the Palo Alto, it will basically process at the ingress stage. Okay. Then it will do the flow lookup. Then slow path of firewall session setup state. Then fast path will start from here. Then your app ID. And after that, we have your content inspection, content ID, and your forwarding stage or egress processing. And your actual single pass software is applied here at the content engine. Okay. I will tell you how it applied. So, according to this particular diagram, you will see your ingress stage, your flow lookup, your slow path or fast path. All these tasks done by the Octeon chip, which is your data plane CPU or your security processor, the middle component of your data plane. Then app ID and content ID done by the Jaguar chip, and your forwarding is again done by the Octeon chip. Now you can ask why we have this particular processor, network processor. This particular processor is act as a session offloader. Means if some session is offloaded by this Oction chip, means this particular chip tells to this particular processor, this is the session and these session you need to handle. And when it will offload any sessions here, and after that ingress stage, flow lookup, slow path, fast path, forwarding stage is done by this Liger chip and Tiger chip. Okay, it is act as a session offloader, and we will discuss later because it's a little bit big topic. You have to understand all the things with regards to this session offloader. One more thing. Let me show you this particular diagram so it will also clear your doubts. I hope guys my screen is visible to everyone and I'm audible properly. Just confirm. Are you able to see this particular diagram, guys? Okay. So this is the diagram of your Palo Alto Firewall 5000 series box. In this box, you can see what we have: a switch fabric where we have a Petra chip. So this is the same chip like we have a Marvel chip or the Petra chip, right? All your interface has a connectivity with this particular chip. Okay. And after that, we have a network processor where we have a Tiger chip. Network processor can do the flow control. Flow control means session related task, session management, route lookup, ARP lookup, MAC lookup, and the net lookup. Okay. Then we have a Oction chip, which is a security processor or data plane CPU. And guys, in high-end boxes, we have a 3 data plane CPU: DP0, DP1, and DP2. And they have a dedicated SSL engine, dedicated IPsec engine, and dedicated decompression chip. These are the dedicated hardware component they are having for doing your complex task like SSL related, IPsec related, or decompression related. And we have a multi-core CPU here, and they have a dedicated RAM and CPU as well for processing your packets. Okay, and we have a signature match processor where we have a Jaguar chip. Here we have a 2 signature match processor, means they can able to do lots of tasks with regards to FID. And why they've introduced here 2 signature match processor? So our task can increase or the performance of your Palo Alto firewall increase. Why they are having here multi-core CPUs? Why? Because PA 5000 series is the very high-end box you will see in the data center environments. In DC we have a lots of traffic. Okay. And we have a control plane here. This is your known as your management plane. I hope you got the point here. Hardware, parallel processing hardware means now. Let's take an example. Let's suppose we have received a packet. We have received 3 packets, packet 1, 2, and 3. Maybe these particular packet, when they reach a maybe first packet processed by this engine, second packet processed by this, and third packet by this. Means all these 3 packets getting processed parallelly at the same time, right? This is known as the parallel processing hardware. Okay. So this is the first component of your SP3, parallel processing hardware. Let me go back here. So this is like architecture, right? Now let me just tell you what is single pass software. Okay, so in single pass software, what used to happen? Let's take an example. Right now, your packet is at Jaguar chip, or your packet is at signature match processor or pattern match processor. Now, you, as I have mentioned, guys, we have a content ID, right? In content ID, this task is done by the Jaguar chip, and in content ID, the main feature is your antivirus protection. Then we have a anti-spyware protection. Then we have a vulnerability protection. We have a URL filtering. We have a file blocking. Then we have a wildfire. We have a data protection. These are the main features available at your content engine, right? So now what used to happen generally? Let's take an example. See how Palo Alto Firewall going to do all these tasks, how it will do the antivirus protection, because you know it has a signature database. For anti-spyware also it has a signature database. For vulnerability also it has a signature database, right? For URL filtering it has a predefined categories, right? For file blocking, for wildfire it has a signature database. For data protection it has a signature database and all, right? So what used to happen when your packet received by the firewall at content engine, what it will do? In your content engine generally, all your databases are available. So let's suppose we have a AB database here, anti-spyware database here, vulnerability protection database here, right? Then your URL filtering here, then we have a wildfire signatures here, right? Now, what used to happen? Now, as soon as we will receive a packet, so generally at your content engine, it will not get a full packet. It generally only get the layer 7 information from the packet. So when it received that layer 7 information, it used to store that information into these memory locations. Into these memory location, it has stored that particular layer 7 information. And what it will do now, each of these databases, what they will do, they will load that particular information from these memory locations, and they will basically match that particular layer 7 data against the signature database for different threats, for different type of malwares. Okay, and what they will do, they will basically give the results back to your Jaguar chip. If there is any type of malicious content they have found, what they will do, they will inform that information right away to your Octeon chip, which is your data plane CPU, and your DP CPU will basically block that traffic right away. And how it will block? It will basically drop all the packets and will basically change the action into your session as a discard. And that's how basically your single pass software stuff work. Means what used to happen, your packet just loaded once in the memory, right? And it just got processed against all these particular layer 7 features just in single go. Okay, this is your single pass software architecture, guys. So this is the topic which I wanted to cover with regards to your today's session. And if I do have one more diagram, let me just show you that diagram. PCNSC day 1. And after that, we will bind up this session. Where is that one? Yeah, this is the one I just wanted to explain the multi-pass architecture. So we have seen the single pass architecture, right? So if you know the multi-pass architecture, you will get the idea. You know, in multi-pass architecture, what used to happen when any firewall, let me just give you the example of Cisco Firepower, Cisco FTD. In Cisco FTD, what used to happen? We have a ASA on it. Then we have a source fire, right? So FTD is a mix of ASA and source fire. At ASA, we have a Lena engine. At source fire, we have a snort engine. And on top of this source fire, they have also added the URL filtering engine. So what used to happen when you receive a packet, that packet first loaded at the Lena engine, which is a ASA code, and it will do the processing at layer 2 to layer 4. And after that, that packet basically loaded by the URL filtering engine, it will do the URL filtering. Then packet is again come back. Then now it is loaded by the snort engine, it will do the IPS functionality. Then your antivirus functionality. So here if you will see, this particular part is repeating all the time, right? This task is repeatedly happen. This is the multi-pass architecture. It's not like that they are storing packet once in the RAM and all that particular processing they are doing just in one go. No, it's not like that, right? Your packet come back from Lena to snort, snort to Lena, and that's how they are doing the processing. Okay, so that is the multi-pass architecture, guys. So these are the topic which I wanted to cover in your today's session. Now, if somebody interested for this Palo Alto Firewall training only, then cost is 7,000. These are the two numbers you can reach out to on these two numbers. First number belongs to me and second number belongs to Vidit sir. If you are interested for F5 LTM plus Palo Alto both, then cost is 12,000. Okay. So guys, that's it for today's demo. Thanks for joining. Now, let me just have a Q&A session.